Everyone, in this video we are going to solve the problem number 1.37 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves along the circle with a velocity v is equal to at, where a is equal to 0.5 meter per second square. Find the total acceleration of the point at the moment when it covered the nth fraction of the circle after the beginning of the motion. Okay, so let us say this is the circle in which the point is moving. For example, at this particular time instant, let us say at t is equal to 0, it is starting from this particular distance and it is covering the total distance of nth fraction of the circle. So let us first find out the total perimeter of the circle, or the total distance covered by the particle if it is moving in the entire circle. That we can write it as distance is equal to perimeter of the circle, that we can write it as 2 pi r, where r is the radius of the circle. Now it is asking to find the acceleration at the time instant where it has covered the nth fraction of the circle. So let us say it has reached to this particular point, time instant of t. This is the nth part of the distance. Okay, so that we can write it as, let us say s is equal to 2 pi r into n, and n is given as 0.1, so we can write it as 0.2 into pi into r. So this is the value of the distance we got. Okay, now the expression of velocity is given as a into t. Okay, so we have to find out the tangential and normal component of acceleration. So at this particular time instant, this is the tangent, so the acceleration, tangential acceleration, will be in this particular direction. Let us represent it by at, and the normal acceleration will be towards the center. Let us represent it by an. Okay, so the tangential acceleration we can write it as derivative of the velocity in the tangential direction, and we know that at any time instant the velocity will always be in the tangential direction. Okay, so here we can write derivative of the velocity, that we can write it as d by dt of at is equal to a, that is 0.5 meter per second square. So basically the tangential acceleration is constant at all the points and it is equal to 0.5 meter per second square. Now let us talk about the normal component of acceleration an. We can equate it to v square by r, where r is the radius of the circle. So we can write v is given as at any time instant of t. So we can write a square t square divided by r. Now in this particular expression we don't know what is the value of t, and we also don't know what is the value of r. So let us make use of this particular distance. We can write the distance is equal to speed into dt from t is equal to 0 to t is equal to t. Now the value of speed, we can write it as the magnitude of the velocity vector, that is equal to at. Okay, so we can write it here at times dt integral t is equal to 0 to t. Here a is constant, so we can take it outside. We can write a into, and the integration of t is t square by 2, from t is equal to 0 to t. So we can write at square by 2 is equal to s, which is given as 0.2 into pi into r. Okay, so from here we got t square is equal to 0.4 pi r by a. Okay, so this is the expression of t square we got. Now let us substitute the value of t square in this particular expression in order to find the normal acceleration. So we can write the normal acceleration is equal to a square t square whole divided by r, that is equal to a square into 0.5 pi into r whole divided by a into r. So r will get cancelled, a will get cancelled, and we can get here 0.4 into pi into a, and the value of a is 0.5, so we can write it as 0.4 into 0.5 into pi, that is equal to 0.2 into pi. So this is the expression of an we got. Okay, now we have to find the total acceleration of the point. So we can write net acceleration is equal to an square plus at square under root, because both an and at are mutually perpendicular to each other. So we can write 0.2 pi whole square plus 0.5 whole square under root. So from here, if we calculate this particular value, that is 0.2 into pi whole square plus 0.5 whole square under root, so we will get acceleration is equal to 0.8 meter per second square. So this is the value of the total acceleration we got at any time instant of t. Okay, so I hope the entire procedure is clear. Thank you.